Hey guys, we're looking at product of functions today. So this is following straight on from our sum. So when we were adding our functions together, so straight on to product. So we're just multiplying two functions together. And once again, the exact same way as our sum, we can do this in two ways. We can do it by algebra if we're given the equations, or graphically. Okay, so let's go straight away look at the algebraic method. Now remember the Maths in Focus textbook, this is what they are only testing. However, I will be covering doing it by just given the graphs. It is something with a deeper understanding you should know. So the first thing we want to do is just multiply the functions. Okay, this example tells us that if f of x equals that and g of x equals that, well, what is f of x timesing by g of x going to be? So I would set it out straight away, show the marker that you know what it is. Don't try and do it in your head. Show them you know it's just the product of the two functions. And then it's just a matter of expand it out and gather like terms. Once you do that, I'm going to call my answer h of x. And when you expand this out, so FOIL it out, you'll end up with x cubed minus 8. Now all we have to do is draw h of x, okay? So one thing I might write so the marker is aware that I'm going to let f of x multiplying by g of x equal h of x, just so they know what I'm talking about when I say h of x. So then it's just a matter of sketching this graph. And we all know, hopefully, our power of 3 is a cubic, and minusing 8 just shifts that cubic down 8 places. And then we know the general nature of our cubic. And there's the graph. That's it. Okay, so again, if you got h of x was an uglier function, just use your knowledge of functions, sketch it as best you can, or do your table of values. And it's as simple as that. So then now we move on to solving it graphically. Alright, so now graphically, so there are three big things to think about now and just have that deep understanding of how these will work when we're multiplying. So let's think about these three things that I've said. The first thing is the x-intercepts stay the same. So any x-intercepts either f of x or g of x have, h of x will have all of those intercepts. And think about the reason behind that. I've done an example here of a very rough diagram of a parabola and a straight line. It's meant to be anyway. F of x and g of x. When I'm multiplying these together, if we think about it logically, that first thing says all the x-intercepts will stay the same. And that's simply because an x-intercept is at our 0, okay? So multiplying that by whatever the function f of x would be there, it's still going to give us 0. So all x-intercepts, you're just multiplying by 0, which gives you 0. Hence why all the x-intercepts stay as x-intercepts. Okay, so that's the first thing. Now the second thing. If one function is in your negative region, so no, I'm talking negative as in below the axis, okay, my y value in other words, or the function value I should say. If the function is negative and you're multiplying it by the other function, if one function is negative and the other function is positive, it's going to give you negative. What I mean by that is if one function at a certain x value, let's say for this example here, I'm talking about the value x equals a half. That's a nice one. Let's think about at that x value, my g of x is in the negative region, but my f of x is in the positive region. So I've got a negative and a positive function at that point multiplying together. Just like your negative in numbers, a negative and a positive will times together to give you a negative. So that's the first one. So then the same idea. If both functions are in that negative region, you're going to get a positive, okay? In this particular graph, there is no times where that happens, okay? So there is no time where both functions are down in that negative region at the exact same point. But then the last one says, if both functions are positive, you'll have a positive function, which makes sense because we know two positives still give a positive. So what that means is, let's take the value of 1.5, okay, the x value of 1.5, 1.5. It has both functions in the positive region, which is going to give me my h of x in the positive region, okay. So you can know whereabouts in your axes your function should lie. Now the last thing is, I always just double think about that overall nature of this. What I actually have here, g of x is some sort of parabola, so x squared something 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 something. In fact, I could probably work out that it's just x squared minus 1. Anyway, we're doing this without the equation. And then I'm multiplying that by a straight line, which is just the power of x. And again, I could work out what this power, the exact line is. Looks like x plus 1. But again, I'm doing this without the equation. When I multiply a power of 2 with just a power of 1, I get x to the power of 3. When we added our functions, our power didn't change. But now that we are multiplying our functions, the power does change. Okay, so what that means is I'm going to get a cubic, all right? We know the idea of cubics, okay? They're going to have at most 2 bumps. So now let's put all that together. My blue dots are the definite dots. I'm going to use yellow as my working out color, but then blue is the definite dots that it passes through. Let's think about this for now, okay? Let's have a look. Both of the functions here have a function value of 3. Okay, so it's dotting straight across to my 3. So let's think about that. 3 times 3 is 9. So at that x value of 2, my function h of x is going to be skyrocketed up to a function value of 9, which is just literally way, way, way up the top of the whole page. Off the chart, they would say. All right, now let's keep thinking about that same idea with our different values. Let's think about it at 1.5. We've got an a y value of about 1 and an x value of about 2.5. So when I multiply 1 by 2.5, that's interesting. 1 times 2.5 is still going to be 2.5. So there's my second point. All right, let's shift over a bit now. Now I've got, let's see, x value of 1/2. Let's think about this. Okay, well my parabola's down here at, let's just round that to a nice fraction, -1/2. It's a little bit more, but -1/2. And I'm timesing -1/2 by what, 1.5? Okay, so again, I'm timesing a negative by a positive. I'm going to be down here at my negative. And let's think, without a calculator, 1.5 is 3 on 2 times by -1/2 approximately gives me -1.5. So that tells me that I'm down around here. Okay, let's think about on our axis now. We're at a y value of 1 at our origin here and a y value of -1. What's 1 times -1? It's -1. So I know I pass through here. Okay, now let's think about, well, I'm starting to get a bit of an idea of what this is going to look like here. I'm going to have negative values up here because I'm having 1 in negative, so that's still going to be in the negative region. It's going to come up and hit this value, but then it's got to stay back down the negative region after that because I've got a negative line down here. So negative values timesing by positive values, so that is going to give me more negative values. Okay, so now let's link everything up. This is my peak here, and it goes all the way up to that dot I had up the top, and there I have h of x. Okay, so it's really focusing on those 3 steps. What I'd like you to have a go at now is pause the video and get those notes down. Once you've done that, give this one a try. So pause the video here, copy that out, give it a go. Otherwise, now I'm going to assume you've pressed play. After you've given it a go, let's see what you should have gotten. So, step 1, x-intercepts. We've got an x-intercept here, so I know my h of x passes through there and my h of x passes through here. Alright, next thing I know is where it's positive and where it's negative. Alright, so let's think about that. We've got both in the positive region, so I know that, and I'm going to use yellow as my little working out color. I know that I'm going to be up in this positive region. Then I've got in between these 2 values, 1 in positive, 1 in negative. So I know I'm going to be down in negative in here. So my yellow dots are just telling me whereabouts I'm going to be. Then after that I got both in the positive region again. So then I'm going to be, oops, sorry, I shouldn't have put some dots in there, overlapped a bit. From 1 onwards, so technically I could have some dots here, but all of this, so I'm getting a bit of an indication by those yellow dots whereabouts my graph's meant to sit. And let's think about this. The third rule was x squared times x squared. What's the overall nature? A quartic. Now your basic quartic is like a flat parabola, but know that quartics can have up to 3 bumps, all right? Okay, so now let's think about our values. So let's think about the value at 3. I've got a y value just under 2 for this one, and a y value of, well, what would that be, about 4. So I'm doing 2 timesing by 4, which gives me 8. So at the x value of 3, I'm way up, which is off the chart again, up here at around 8. Okay, so there's 1 dot. I should do that in blue. Alright, next thing I have is, let's test, we know that what's happening at the point 2, let's test 1. Here at 1, I've got 1 above, which looks like it's just underneath the value of 1. So I'm thinking, okay, well, just underneath the value of 1, let's say 3/4. This is the point here, about 3/4. And below here, I'm underneath 2. So let's go 2 multiplying by 3/4 gives me 6/4, which is then the same as 1.5. So that tells me that I'm going to be sitting down here at about 1.5 in the negative region, because technically that's a -2. Alright, -1.5 about here. Alright, now the next one is, let's just think about when one of the parabolas is equal to 1. So this one here has a y right here, whatever that x value is, it's got a y value at 1. We know that when we multiply anything by 1, we just get the same thing, which tells us it's going to hit the other parabola here. Okay. Alright, so we can sort of start to see, it's looking a little bit strange, but let's just keep going. Let's do our axes now. We've got +2 timesing by -2. That's going to give me -4. So it's down here somewhere. So it's going to hit my axes, my y-axis at -4. And then it's going to pass straight up to the next blue dot here. After that, what I've just got are positive values timesing by positive values. Okay, so let's think about over here. Let's say let's go out here to 2. Okay, I've got some big number multiplying by some other big number. It's going to be way up. All right, so I know it's going to be, again, off the chart there. So let's just link what I have here all together. So that dot was up here, so I'm looking like I'm going to be, and then comes, my computer does that all the time. And it comes down here, and then it shoots up here, and then it's going to exponentially grow up there. And there I have it. So guys, have a go at the exercises in the Maths in Focus textbook. It's in the same chapter as our sum of functions. Okay, you'll see them. Again, they only focus on the algebraic method, and I'll give you a printout in class of some that will cover this graphic method. Okay.